So the pandemic kind of changed many things about our business and about how our customers are using robots. The first thing that changed is there was a redeployment. So robots that were in areas that were considered elective, like orthopedic operating theater, some other procedural areas, those robots were all redeployed to the front line. So they were redeployed to the emergency department, to respiratory care areas, to testing areas. And we've also seen a lot more use of the robots in non-clinical areas. So we see robots used within the hospital setting, in the executive areas, the reception areas, waiting rooms, all of these areas that are posing concern now. We see that in hospital settings. If you mark a surface with a black light dye and then have people come in and clean and then come back and look for that fluorescent marker, and an overwhelming number of studies, and tens of thousands of rooms, the average is about 50% of high-touch surfaces really get disinfected between patients. What the light lets us do is really just kind of automate that process and make sure the light, anywhere that the light gets is getting its disinfection, anywhere the UVC light is getting. And so we're really automating the process. UV light eliminates microbes by using this high energy UV. So we know UVA and UVB, we're all familiar with those, and put sunscreen on to protect ourselves. Well, there's something called UVC that's also produced by sunlight, but filtered by the ozone layer. So it doesn't naturally occur on Earth. So if you add more energy and you get to the UVC spectrum, viruses and bacteria, spores and fungi, they haven't evolved to develop resistance to those wavelengths. And so what it's doing is it's putting this high energy UV, again, UVC, so from about 200 to 280 nanometers, and that penetrates the organism, and at different wavelengths has different effects. It can do everything from cause photo cross-linking and actually lyse or burst a cell at some of the lower number, like the 220, 240 wavelengths. And it can also be absorbed by the DNA or RNA of an organism and basically mess up the information. And that organism, we say, is deactivated. It can no longer replicate. It's really different, so obviously a very different approach than the chemical approach. So in chemicals, they're using hydroxyl radicals and other means to attack the cells and create these reactions. The difference really is what, in my opinion, is reliability. When we first started putting robots into hospitals, we had a couple challenges, and one of them was, sometimes a rumor would get started on the staff of like, oh, they're bringing in these, cleaning robots, so they're going to replace our jobs, and it led to some misunderstandings. So we learned, very early in the company to include everyone in the implementation and when we bring a robot in. And what we emphasize, especially to those frontline housekeepers and cleaners and environmental service workers, we really want to emphasize that, the pathogens have evolved. We've got COVID now, we've got these resistant organisms. The stakes are really high in terms of we've got to make, spaces safe and pathogen free. But until the robot came, their tools really haven't evolved. They've got mops, they've got buckets, they've got wipes, and they've got stuff to spray. And, the pathogens evolve, the tools don't evolve, that's not good. They can't do their job. They need a new tool, and that's the robot. The robot's their new tool, the new partner. And we really want to emphasize that with the staff so they don't feel threatened by this technology.